All right, good afternoon. Today we are actually going to be finally getting into correlations. It's something that you've been doing a correlational study all semester, but today we're actually going to start talking about correlations. But before we get there, I kind of just want to talk about the remainder of the class, or I guess specifically the final exam. So I'm changing things up for the final exam. Traditionally, it's just a bunch of multiple choice. It's like a normal exam, but a little bit longer. There's more multiple choice questions and more of those short answers. I'm actually switching things up a little bit. So instead, the format for the final exam will be a shorter like multiple choice section. So there's only going to be about 15 multiple choice questions. There's going to be like two short answer. Those numbers could fluctuate by a couple. I haven't finalized the final exam yet. And you're going to have all day to do it. It obviously won't take you all day, right? The normal exam takes most people about 40-ish minutes. This should probably take about 25-ish minutes, right? It's about half the size of a normal exam. So that's going to be the closed book section. You take it through Respondus Monitor like normal. It's a normal shorter exam. Then there's going to be an open note section. So starting at 1:30, I'm going to email you, or I guess allow it to be viewed on eCampus. But there's going to be an open note section, and I'm going to call it the applied section. What this is I'm going to give you a data set on SPSS and some information about the variables and the research and the general research design. And you're going to have to answer a bunch of questions with it. I'm going to talk more in like next week about this, and I'm going to give you some examples and an example data set and example questions to work with. But you're going to have to be able to do a one samples t-test and a correlation on SPSS. Um, you're going to have to answer questions like, is it significant? Do an APA write-up. Find me the mean, median, and mode of some of the variables. I'll talk more about it next week, and I'll give you like a Word document of everything that you're going to need to know how to do for this applied section. I highly suggest that you have your notes ready. Like you have Word documents or however you're keeping notes of like, here's a step-by-step how to do a one sample t-test and how to interpret the output, because that's what you're going to have to do in the exam, and you're going to be able to use your notes. But you only have from 1:30 to 2:15 to do it, which should be plenty of time if you know what you're doing, or you have your notes available. But what people may struggle with is if you don't know how to do things like a one sample t-test or a correlation, right? You don't know how to do them in SPSS, and then you're trying to like scrounge through your notes as the test is going on. That won't work. You may run out of time if you do that. So I highly suggest having your notes all laid out nice and neat with step-by-step instructions for how to do things and how to interpret these outputs. Once again, I'll send you more information on that next week. But I just wanted to update you. This is what the final exam will look like. Any questions about this limited information I gave you? More details will come later, but any quick questions right now about the final exam? Let me open up chat. All right, not seeing anything. Once again, we'll talk more about this later. I also wanted to bring up the overview of the paper or what's going on. And once again, I will also bring this up next week as well in a little bit more detail on Wednesday. But so far, and I have some common problems I've seen with people papers under each one, but let's go through it. So for the introduction, which should be assignments 4 and 7, some major problems I've seen so far are people are missing sections in their introduction. So go back to assignment 4, go back to assignment 7, and make sure you have every paragraph that you need, right? Everyone needs that intro paragraph. Then you need 2 paragraphs where you talk about how your independent variable and your dependent variable are measured in previous studies. So you need 2 separate paragraphs with that. And then you need a couple other paragraphs. I'm not going to go into detail. You can go back to assignment 4, assignment 7, go back to the lectures and watch. Just make sure that all of your videos or all of your paragraphs are there. So for the methods, make sure that you update that descriptive information from the previous homework assignment for your participants. So make sure you have things like, what were the percentages of ethnicities, genders, all that good breakdown. A common problem I've seen with the results is that people aren't using the paragraphs that I gave you. So like, for example, in that one sample t-test, whatever homework assignment that was, 9 or 10, um, whichever one it was, people aren't using the paragraphs I gave you. So make sure I give you the one sample write-up, um, and I'll give you the Pearson correlation write-up. Make sure that you're just copying and pasting those paragraphs and changing out the numerical information that you need. So like, don't try to reword the paragraph or the sentence in any way. Use the exact results paragraphs that I give you. Yeah, you're just going to get points off if you don't use those paragraphs. The nice thing about results in scientific writing is that they're pretty standard. You don't have to interpret or add your own interpretation. Don't worry about plagiarism. Just copy paste those paragraphs I give you, change out the numerical information. Finally, make sure you're incorporating my feedback. Even if you get a 15 out of 15 on your assignment, you probably most likely have feedback on it. Download the feedback from eCampus. I always upload feedback. Occasionally I'll email it to you if it's a group assignment, but go to eCampus, look at your grade, download my feedback that I give you, and actually open the document. It's not enough to just download it and look at it. Like, download it, open it, and you'll be able to see my feedback along the right-hand side. So make sure you're just incorporating the feedback. All right, so let's move into, actually, are there any questions about the paper or the final exam? Once again, we'll talk more about this next week, but any questions so far? All right, good. All right, cool. So let's jump into correlational studies. I'm going to assume that you guys all watched that really short 4-minute video I sent out prior to class. We're going to cover most of what's in that video anyways, but some things I'm just going to glance over because I thought that video did a really good job at explaining it. Anyways, what are correlational studies? Hopefully this is pretty apparent to you because we've kind of been talking about correlations throughout the entire semester, but correlational studies are just studies that involve examining the relationship between two variables, just as simple as that. So its purpose is to describe naturally occurring relationships between two variables. We're not looking at how one affects the other in some experiment, right? We just measure one variable, we measure the other variable. They're not related. They're not necessarily related in any way, right? Like, one doesn't cause the other one. We're just looking at how one variable is naturally related to another variable. We'll talk about things like the IV and the DV. We've talked about the difference between an independent variable and a dependent variable prior, and I'm sure all of you know what an independent variable is, what a dependent variable is. But these two in a correlation are interchangeable, really. However, we will use things like IV and DV just to refer to the two variables. But in reality, it doesn't matter what you pick your IV to be or what your DV is. It doesn't matter in a correlation. But we can still apply, this is an IV, this is a DV, just to give them some labels. All right, so correlational studies, just examining the relationship between two variables. So some questions we might ask under a correlation are, is X associated with Y, right? These are just, any random variables. Is the amount of exercise associated with stress? Is the amount of social media that you use associated with your mood? Is something related or associated with something else? Simple question. You can also word it in slightly different ways depending on what you're actually measuring. So we could see, how does Y change when X changes? We're not saying how does Y change X. We're just saying, how does Y change when X changes? What's the relationship there? So how does sleep quality change when number of children changes, right? Probably participants who report having more children have lower quality sleep, or less sleep. Sleep quality have lower quality sleep. Just asking about the relationship between two variables, not saying one causes the other. We're just looking at the naturally occurring relationship between the two. Like this says, and I've been repeating this all semester, correlation does not imply causation. That goes back to that. We're just looking at the naturally occurring relationship. All right, designing a correlational study, who to test. Once again, like any study, You want a representative sample, always try to increase representativeness. And we talked about ways to do that in our sampling lecture a couple weeks ago. What to measure? So what kind of data do we need when we're doing a correlational study? Well, we need variables representing 2 or more. You can run a correlation with as many variables as you want, but let's just stick with 2. Variables representing 2 constructs of interest. And so this measurement can be through observation, it can be physiological techniques, self-report, it doesn't matter. However you want to measure this variable, you can measure it. And then of course, taking all the considerations that we talked about before of high quality measurements, right? But that was a previous lecture. So the scale of measurement is actually really important for a correlation. Either interval or ratio. But what this really means, right? And you should know the differences between like ordinal, interval, all them. But really what it comes down to for Pearson correlation analysis, and that's what we're going to be focusing on today, a Pearson correlation. There's a couple other correlations that we'll talk about on Monday. But for a Pearson correlation, both variables must be measured on a quantitative linear scale. So just some scale that ranges numerically. We'll learn about we'll do it on Monday. Other types of correlations can use different types of data, but for a Pearson correlation, our main correlation analysis, the one that you really need to know, it has to be a numerical quantitative scale, right? So any traditional scale that you can kind of think of, right? Self-esteem, depression, whatever it is, all the scales that you guys came up with are quantitative linear scales. An example of something that's not a quantitative or linear scale could be like gender, right? Gender is dichotomous, it's categorical. Ethnicity, it's categorical. You can't do a correlation with that type of data. It has to be a data on scales that vary numerically. All right, so that's your main component of data, just 2 variables that are quantitative. Simple. So we can have non-directional and directional and null and alternative hypotheses for correlations, and here's how they could be worded. So a non-directional null, once again, what is a null? It just says there is no relationship between the 2 variables, right? And that's what a null hypothesis is in any test, right? With a t-test, there is not a difference between the 2, right? There's no difference. So with a correlation, there's no relationship between whatever your 2 variables are. And here we can see it visual. I'm not going to ask you the visual, but this might come up in 204 because some professors like to use it. I don't like the symbols. I like the words much better. But here are the symbols. The alternative hypothesis is just, hey, there is a relationship between our 2 variables. This kind of caught people in the exam, the difference, a couple people, the difference between null and alternative. Remember, a null for a Pearson correlation or for a correlation is there's just no relationship. For a t-test, there is no difference between our 2 groups, right? Null is just whatever your alternative is, no, there is no relationship. So alternative with non-directional, obviously there is a relationship between the 2 variables. So we can also make directional hypotheses. Let's start off with the alternative. And this is something that your groups all came up with. At the beginning of the semester, you came up with a hypothesis saying, hey, we think this is related to that in some way. So we think there is a positive relationship between exercise and self-esteem, where there's a negative relationship between exercise and stress, whatever. So that's your alternative directional hypothesis. We think there is either a positive or a negative relationship between whatever our 2 variables are. And then the flip of that for the null directional, there is not a positive or negative relationship between our 2 variables. Simple, you can apply that directional and non-directional null and alternative hypothesis to correlations, just like with any other statistical test. Any questions about the hypotheses? I know that tricked or that stumped a few people in the exam. Some people were struggling with it. Does this logic make sense? All right, not seeing any questions in chat or no one speaking up. So let's move on to interpreting correlations. And so the main way to interpret correlations is numerically, but we'll get to that. But you can also kind of gauge or get an idea of correlations by looking at scatter plots. This is something you have to do for your homework assignment and your paper, and we'll walk through creating a scatter plot. But essentially, all a scatter plot is it plots two variables. It plots the scores of two variables. So let's just pretend, your x-axis is social media addiction, and this y-axis is depression. And so the how you plot a scatter plot, or how SPSS, or if you do it by hand, whatever, is the x-axis down here, social media addiction, whatever your first variable is, and it goes from low to high. So low social media addiction, high social media addiction. Then, depression, whatever your other variable is, low score, high score, right? It's a basic graph. And so you can kind of gauge if there's going to be a positive or a negative correlation depending on the direction of the graph. And I believe that YouTube video talked about that. But you can also gauge if it's a weak or a strong relationship. And so this text on the bottom kind of gauges this idea of a correlation visually. So if I know what someone's X score is, so their score down here, do I also know their Y score? So if I know someone's social media addiction score, do I also know their depression score, the score that's graphed on Y? So if the answer is yes, 100%, you have a really strong correlation. If the answer is no, I can't guess that, or I can't know that, and I'll show visually that in a second, then you have a weaker, or you potentially have a no correlation. So what do I mean by this? All right, so let's pretend this, this is social media addiction on the x-axis. Let's pretend I chose, if I know that someone scored a 7, right? Let's just pretend this value is a 7. Do I also know their depression score? And we can see this example on the left is a really strong correlation. Let's go to 7. This participant, I know exactly what this participant said for their depression score. So if I know that participants who said 7 on the social media addiction score said whatever this value is on the depression score, let's apply that same logic to this weak correlation over here. Once again, if I know that a participant scored a 7 on the social media addiction scale, can I tell you for sure what they scored on the depression scale? Well, no, because we can see here's what all the different participants said. Participants who scored a 7 on the social media addiction scale had a lot of different depression scores. This person had a really low depression score, this person had a really high depression score, and it varies. So I can't for sure tell you what someone's Y score is based off their X score. So that means there's a weaker correlation. All right, so that is just visually this kind of logic behind a scatter plot. No one ever does this, right? You can look at this and have a general idea, okay, this is really strong, this is weak, but you need numbers to actually tell you. So let's get into that. Interpreting the correlations as an actual researcher would, and that's numerically. So you'll see in a couple slides, SPSS output for correlations is actually probably some of the easiest to interpret. It only gives you 3 numbers, and you really only need 2 numbers out of that. And one of the numbers is this correlation coefficient, and it's sometimes referred to as R. You'll see, I don't know what the new versions of SPSS, what you guys have, it may call it R on the output. It may say Pearson's correlation. But yeah, either or, correlation coefficient or R. So what is R? It's a statistic that summarizes the degree and direction of the linear relationship between 2 variables. This idea of linear relationship will come into play on Monday. Just put it in the back of your head, but don't focus too much on it today. So this number, this R value, you'll see will range from -1 to +1. It can only be -1 to 1. If it's outside of this value, you did something wrong. Like there's something very wrong with what went on, and it should never go outside these two values or outside of -1 to 1. So this number tells you two things. It tells you the direction of the correlation relationship, whether it's positive or negative. So whether it's a positive correlation or a negative correlation, and it tells you the strength of the relationship. We're going to talk about both of these today, but we're really going to focus on the first one. There's like a 5-minute mini lecture that I'll upload that talks about the strength of the relationship more in depth. So it tells you two things, direction and strength. So let's talk about direction. The sign, whether it's a positive or a negative number, indicates the direction of the correlation. So the first thing, well, after you determine if it's significant or not, you just look at this number, and if it's positive, it means it's a positive correlation. If it's negative, it means a negative correlation. What are positive correlations? Hopefully this should just be a review. We've talked about this many different times, but a positive correlation is simple. It's just as one variable increases, the other variable tends to increase. So let's say we measured aggression in parents and aggression in children. More aggressive parents is going to be related to more aggression in children, right? High time spent studying. People who study more are going to have higher grades, right? A higher value on one variable is related to a higher value on the other variable. Or vice versa, a lower value on variable 1 is related to a lower value on variable 2. I'm going to have a visual representation of this on the next couple slides, but so that's a positive correlation. Negative correlation is kind of the exact opposite. As one variable increases, the other variable tends to decrease. So people who report higher amounts of exercise traditionally have lower BMI. People who skip more classes have lower grades in school, right? More of one variable is related to lower of the other variable. Hopefully this difference between positive and negative correlation isn't new to you. We've kind of been talking about it, or I've been referencing it all semester, and I believe people have had experiences with correlations prior to this class, so hopefully it's not a new idea. But I want to show you this visually, because I think if you are struggling a little bit, the differences between positive and negative, visually this may help. So let's look at study time and exam score. And on the left-hand side, I plotted this variable study time. So let's say our scale ranges from 0 to 4 hours. So you can see I started off with the low score, and I just listed off the values all the way up to 4. Now I don't need to do this. I could just have this idea of low score and high score in red for study time. However you measure it, whether it's minutes, hours, study sessions, it doesn't matter. The key point is the low scores on the bottom and the high scores on the top. So let's apply that same logic to exam score, can range from 0 to 100, right? 100%. And I have them listed out here, but once again, all I care about is low score and high score, right? A low score on this exam is at the bottom, a high score on this exam is at the top. So what's a positive correlation? Well, it's just people who report high scores for study time report high scores for exam scores. So high score is related to high score. Low score is related to low score. I don't care about the actual numbers. It's just that logic of participants who report more study time report more score or higher score, higher exam scores. So let's apply that logic to a negative correlation. This time I have self-esteem and I have depression. Here's a low score, so low self-esteem, high score, high self-esteem, low score, low depression, high score, high depression. So if we got a negative correlation, which we would expect between these two variables, people who report higher self-esteem report lower depression. People who report lower self-esteem report higher depression, right? Just simple as that. Positive, higher score equals high score on the other one, or low score equals low score on the other variable. Negative correlation, high score equals a low score on the other variable, low score on one variable, high score on the other. It's just applying that high score logic. All right, so hopefully if you're ever struggling with correlations, plot it out like this. Low score, high score for whatever variable, low score, high score for your other variable. If it's positive, high to high. If it's negative, high to low, or low to high. It doesn't matter how you interpret it. One thing I do want you to keep into consideration, though, is always pay attention to how the variable is scored. So can someone tell me what they think the relationship between loneliness and depression is? Is it a positive correlation or a negative correlation? What would you expect? All right, yeah.
Would it be positive if high lonely score means high loneliness and then high depression? It would be, or high score of depression would be high depression.
Good job. Yeah, but I'm seeing people in chat tell me positive as well. Yeah, we would expect that people who report more loneliness will report more depression. But always pay attention to how the variable is scored. So there's actually a loneliness measure out there where low scores equal high amounts of loneliness, and high score on this scale, on this loneliness scale, actually equals less loneliness. And so it can become confusing if you're trying to just in your head interpret a correlation when the scale is really weird. So another example of this is, and then I'll get more into this one, but that self-esteem scale, the Rosenberg self-esteem scale, if you reverse score the other questions, so let's say we reverse scored question, 1, 2, and 3, and we didn't reverse score 4, 5, 6. And if we score it that way, a low score is low self-esteem, a high score is high self-esteem. Well, if I reverse score the other questions, if I reverse score 4, 5, and 6, the scale actually flips and it becomes low scores equal high self-esteem and high scores on that scale equals low self-esteem. And so it can become really confusing if you score your scales in a weird way, like this one. So, in this example, a low score equals high amounts of loneliness. So if we scored our scale like this, we'd actually get a negative correlation, even though we would expect a positive, right? A negative correlation, people who report feeling more loneliness, which is actually a low score, report more depression, right? So a low score on this scale is actually high amounts of loneliness. But that positive correlation would be there if I just reverse scored this entire scale. So I will never do this to you on an exam. I will never or like on a homeworks or anything like that. I'll never give you a scale that's really weird like this. All the scales that I'll give you, a low score always represents like a low value for that variable. So like a low score for this self-esteem scale will always be low self-esteem. If I were to give you this example, a low score on this scale will always be low amounts of loneliness. So you don't have to worry about this for the exam, but do know, depending how your variable is scored, can change the direction of that correlation relationship. Because the logic is always with a correlation, when we're doing these, right? When we stick with a positive, it's always low score on that scale is related to the low score on the other scale. Not, low study time is related to low exam score. It's just whatever this, a low score on the scale. So always make sure that you know what a low score on that scale or a high score on that particular scale means. It's one of the reasons we have you in your methods, and actually several times throughout your paper, I have you say, hey, higher scores mean this for our scale. Or, conversely, you could also say low scores mean this. That's why I have you do it multiple times, because it's important to understand how your variable is scaled or scored whenever it comes to interpreting correlations. But like I said, I'll never have this thing where it's weirdly switched. It'll always represent whatever, a low score will always represent a low value for whatever variable you're measuring. But do know it can become wonky. All right. Hopefully that wasn't too confusing. It's hard to do this without writing on the whiteboard and doing it multiple times. It's hard to do it over Zoom. But if you ever have any questions, feel free to throw them in the chat or email me. All right. So that's the direction, right? If it's a positive number or if it's a negative number, it tells you if it's a positive or a negative correlation. Well, that number, that R value, also tells you something else, and that's strength of the relationship. So the absolute value, so we don't care about the positive or the negative sign now, we just care about the actual number. That number tells us the strength of the magnitude of the relationship. So numbers that are closer to 0 indicates there's no relationship or weaker relationship. And a 1 is a perfect relationship. I don't particularly like this graph down here, but it kind of shows you the relationship. So if there's no correlation between your two variables, they don't overlap in any way. If it's a weaker correlation, right, so the number between 0 and 1 is closer to 0, but it's not 0, but it's closer to 0, so it's a smaller number. They're related, but they're not really that related. The variances, I don't want to use that word. That's too science. It's too like mathematical. They overlap a little bit, right? A higher number, so getting closer to 1, there's a lot more overlap, and these two variables are a lot more related. So that's one way to think about it. 0, they're not related at all. The closer the number gets to 1, the more related they are. That's the basic logic of it. So I'm going to briefly go over this slide, but that mini lecture that I'm going to upload after class, like 5 minutes, talks a lot more about this. So this coefficient of determination, this R squared value, tells you kind of how strong the relationship is. So how do you find R squared? Well, you literally just square the R value. So SPSS will give you an R value, and I'll show you that in a little bit, and you literally just square it. You take that number times itself. And we can see here, it kind of gives you a classification of how strong the relationship is. So let's say we get a correlation, right, that's less than 0.1, and then you square it. You'll get a correlation that ranges between 0 and 0.01 after you square it. So this means that the correlation, while SPSS is telling us that, hey, there is a relationship between these two variables, a correlation of this value, or an R squared value that ranges between these two numbers, really tells us there's really no correlation there. Like it's negligible. The relationship is just negligible. It's there, but not really. And then depending what your R squared value is, and once again, watch the video that I'll upload to eCampus, tells us if there's a weak correlation, if there's a moderate correlation, or if there's a really strong correlation between our two variables. So once again, watch that video. It'll explain more about it. Just know here are the classifications. If it falls between these two numbers, it's moderate. It's the logic to this graph or this table. Yeah, so let me show you this one. So graphically, once again, this YouTube video, I believe, talked about it, the one I had you watch prior to this. This is an example of a perfect positive correlation. So we can see, this positive slope going up. And this would be an R value of 1. And then the exact opposite, we can see the slope going down. It's a negative slope, which indicates a positive negative correlation, or an R value of -1. So if your graph looks like it's trending like this, you'll never see a perfect correlation like this ever in like the real world. It's never perfect. But if it looks like, all your dots are trending like this, it's a positive correlation. If it looks like your dots are trending downwards like that, it's a negative correlation. And then if they're not, if there's no relationship at all, this is no correlation, or an R value of 0. All right, going through that fast because I believe that YouTube video talked about that as well. Yeah, so we can interpret these correlations. So if I just give you an R value, and once again, I'll show you how to do this in SPSS and what it looks like in SPSS, but you can interpret correlations just based off an R value. So if we find, we run a correlation between two variables, how long someone's been dating someone and how much they love that person. And we get an R value of 0.35. Well, we know that it's a positive correlation between these two variables because it's a positive number. So as the number of years dating increases, your level of love tends to increase as well, right? Positive correlation. All right, temperature and swimming. So temperature, let's just say in degrees Fahrenheit, and how likely you are to swim. Someone interpret this for me. Unmute yourself. We have a positive correlation here. Someone interpret these two variables, or the relationship between these two variables. We have a positive correlation. So what does that mean? Anyone want to unmute yourselves?
The hotter it is, the more likely you are to swim.
Perfect. As temperature increases, there tends to be an increase or a greater frequency of swimming. You can interpret it multiple ways. How you interpreted, Patrick, was perfect. All right, how about this one? There is a negative correlation between stress and sleep. So someone tell me what goes in this blank spot. As stress level increase, people tend to get blank hours of sleep per night. Is it less? Is it fewer? Perfect. So as stress levels increase, people tend to get fewer hours of sleep per night. Let's do one last one. We have another negative correlation because the number is negative. As your age increases, your level of vision tends to
decrease.
Perfect. Sounds like people have a good handle on interpreting these two, on interpreting a correlation, whether it's positive or negative. All right, so let's show how to do this in SPSS and interpret SPSS output. So we're going to run a Pearson correlation in SPSS. I have the instructions how to do it here. They're also on the homework assignment with like pictures that go along with it, but I'll walk through it on using SPSS. But you do analyze, correlate, bivariate. 3 buttons that you click. This may be slightly different for some of you, depending on what version of SPSS you have. If it is different, let me know so I can update this, but you should be able to figure it out. It's analyze, correlate, bivariate. Then all you need to do is bring over the variables you want to do a correlation to the variable box, and then you press OK. So let me show you how to do an correlation in SPSS. So here we have my SPSS data set again. All you need to do is analyze, correlate, bivariate, and it'll bring up this new box. Let me go ahead and reset this. And it'll bring up this new box. All right, sort alphabetically. So let me find my 2 variables. So I'm interested in social media addiction. So all I did is find my variable and bring it over. And I want to do depression, and that's CDI on this. Where is it? Right here. And depression. So I have my 2 variables. I have my social media addiction, and I have my depression. And all I need to do then is press OK. So this is what, ignore this scatter plot. This is what a correlation output looks like on SPSS. It is, it's just this box. So let me go back to this. All right. So here's what you need to do. Here's the steps when interpreting a Pearson correlation on SPSS. You saw it's super simple, right? Analyze, correlate, bivariate. Just bring over your 2 variables, click OK. All you got to do. So there's some things you need to do then, right? Is the test significant? Once again, we just look at the p-value. The p-value is less than 0.05, it means it is significant, and you can interpret the correlation. If the p-value is greater than 0.05, not significant. So that same logic, that p-value less than 0.05 significant, greater than 0.05 not significant. People got people got hung up on that. A few people got hung up on that on the exam. Do make sure you know that, because that logic is applied to every statistical test you'll ever learn. P-value less than 0.05 significant, greater than 0.05 not significant. So you determined if it's significant or not. And if it is significant, you can continue on. And now, is the R value positive or negative? right? If it's positive, it's a positive correlation. If it's a negative, there's a negative correlation. Simple as that. And then you can report the strength as well numerically, but I'll show you that in a little bit. But I don't really care too much about that. All right, so a Pearson correlation output on SPSS. Let's walk through it because it can be as simple as two variables, right? And then the graph, let me show you visually once again. If it's just two variables, the output is really simple, right? It's just, your two variables, and here's the correlation, here's the R value, and here's the significance. It's all you need to know. But most of the time you run a correlation with multiple variables just because you're interested. As a researcher, you're interested. So let me break down this output. And this is actually an output for a correlation between 4 variables, but the logic is still the same for just 2. So this first row is the R value. And you can see it says Pearson correlation, and that's the R value. So we see the correlation between social media addiction and self-esteem is negative 0.184. The R value for social media addiction and depression, 0.335. The R value between social media addiction and age, 0.007. So that first line that says Pearson correlation is the R value. And that's what it should be on your output as well. But like I said, it may be something slightly different because you have a newer version of SPSS. It may say R value there. The row beneath that is the p-value. So this is just the significance. We can see the p-value of 0.004. In using the direct message, is that significant or not significant? Tell me in chat. Is this p-value of 0.004 significant or not significant? All right, good. Everyone so far has been saying significant. Good job. It's significant. How about this, the correlation between social media addiction and age? Is it significant or not significant? This box right here. All right, good. Seeing a bunch of people say not significant. Perfect. Because we know that because it's greater than 0.05. All right, so these two rows, we have the R value and we have the P value. I don't have it on this slide, but the box or the row underneath it that's N is just how many participants are in that correlation. Actually, here's a good question. Here's a good thought question. So we see that this correlation between social media addiction and self-esteem has 248 participants. That's what this N represents. Why is this number different between social media addiction and depression? Why is this number 244? Why are these two numbers different? Unmute yourself if you want to take a stab at this. As soon as someone says the right answer, you're going to be like, oh, of course. You're probably all thinking too much into this. Anyone want to take a stab at it?
Were 4 people just excluded from that one, or?
Yeah, why do you think they would be excluded?
Because maybe if they were taking like a survey, they didn't maybe fill out every question or something like that.
Perfect. Yeah, good. So the N just tells you, so we have an N of 248 for this social media and self-esteem. It means that the SPSS logic is we had 248 people fill out both the social media addiction and the self-esteem scale. We see here that number is smaller, so it probably means that 4 people just didn't either do the depression scale, or maybe they were missing, a couple questions from the depression scale, and so we couldn't calculate a full value. That's all the N represents there. Just how many participants filled out both of these. So if I were to ask you, how many participants completed both the depression and the social media addiction scale, all you would have to do is go to this N and say, oh, hey, there were 244 participants. So the N value that you report in your method section where you say, hey, we had 300 participants or whatever the number is, don't be alarmed if that N is different. It just means that, you kicked out a couple people because they didn't fill out the entire scale. So that's what that N means. All right, good job. Good job, Justin. All right, so, okay, here's some more about a correlation output. Hopefully you can see, but the variables I put in go both vertically and horizontally. So if I'm interested in social media addiction, right, I just want to know the correlate, that's my main variable of interest. I could go horizontal, right? I could see the relation or the correlation between social media and self-esteem, social media and depression, social media and age, and its individual boxes. But I could also do it horizontally. So it's the same exact numbers. I could look at social media addiction and self-esteem, social media addiction and depression, social media addiction and age. So it's both horizontal and vertical. And so that means, well, it means two things. So first off, you may have noticed these weird like ones. So there's these boxes that just say one and nothing else. And what that means is, well, there's a perfect correlation between social media addiction and social media addiction. There's a perfect correlation between self-esteem and self-esteem, right? Because they're just the same exact numbers. So the correlation would just be one. So what this means is, what this really means is, let me go here because it's easier to see. You only need to pay attention to either above this diagonal line or below this diagonal line, because it's just itself mirrored. So these numbers right here, so these correlations, these three correlations here, these two right here, and this one right here, are the exact same over here. So you only need to pay attention to either this top half or this bottom half. It's up to you to determine which one you want to read. It just depends how you read this correlation table. All right, so let's say I want to focus in on the relationship between social media addiction and self-esteem. So, reading a correlation output, you just go across and down instead of self-esteem. So all I care about is these three numbers, and really just these two. I don't really care about the end. It's just for my knowledge. So I only really care about these two numbers right here. If I'm looking at the relationship between social media addiction and self-esteem. So someone interpret this for me. Actually, do it in the direct message chat. Is this positive or negative correlation? And is it significant? So tell me yes or no if it's significant and if it's positive or negative. All right, answers are rolling in. All right, so I'm seeing majority of the right answers, and that is yes, it is significant because the p-value is less than 0.05, and it is negative because it's a negative number. Good. All right. So let's just focus in on social media addiction and self-esteem, right? Is it significant? Yes, it is. If so, is there a positive or negative relationship? It's negative. So this is the APA write-up. So this is what I want to see on your homework assignments and also in your paper. So according to a Pearson's correlation test, there was a significant positive correlation between social media addiction. Oh, wait, my bad. This is for just depression. So we're doing this is an APA write-up of a positive correlation. So is the next one, yeah, the next one's negative. So let me do the negative one first because that's what we just interpreted. So according to a Pearson's correlation, there was a significant negative correlation between social media addiction and self-esteem. Then you need to report the R value, which is negative 0.18, comma, the p-value 0.004, comma, R squared, and then you literally just take R value and you square it, 0.03. Once again, watch that 5-minute after lecture, that mini lecture, and we'll talk more about this, but we know that's a weak relationship, right? 0.03, weak. So participants who reported higher, and then now you interpret it in words. Participants who reported higher levels of social media addiction also reported lower self-esteem. See figure 1. So in your own paper, you're going to run a scatter plot for your correlation for your two variables, and that's what figure 1 will be. But the homework assignment that you'll do, we'll talk about that. So that's a negative correlation write-up. Let's go back up to the positive one. And this time we're focusing on social media addiction and depression. So this box right here. And we know it's positive, we know it's significant. So, you can read the paragraph, there's significant positive relationship, you report the R value, P value, the R squared, and then you report the word interpretation of it. So what happens if it's not significant? So here's an example of it being not significant. So the relationship between social media addiction and age, we see a p-value of 0.9. That's wildly not significant, right? What does that mean? There's a not significant. So this is how you do a write-up for a non-significant correlation. According to Pearson's correlation test, there was not a significant correlation between your two variables. You still report the R value, p-value, R squared, and then just simply, this indicates there is no relationship between social media addiction and age. So hopefully you can see, I've given you all the write-ups for whether it's positive, negative, or there's no correlation. So make sure you're using these write-ups. So make sure you're using these write-ups for an exam or a quiz, or the homework assignment. Make sure you know how to interpret this output. So if I were to ask you, if I were to give you, this correlation table, make sure I ask you, hey, what's the relationship between self-esteem and depression? Someone tell me that one. Actually, do it in the chat again. In the chat, what's the relationship between self-esteem and depression? Is it significant? And is it a positive or negative relationship? So once again, self-esteem and depression. Tell me in the chat. Okay, I'm seeing several different answers. All right, I think I've seen every combination of answers as possible here. All right, so this means I have to. All right, let me explain. Let me walk through it one more time. So the answer is it is significant, and it's a negative correlation. Someone tell me, how do we know that self-esteem and depression is significant? You can unmute yourself and tell me.
.002 is less than 0.05.
Perfect.
Is that right?
Yep, perfect. We know that 0.002, and we know that's the box that we should be looking at because we take self-esteem, we go all the way to depression. So we know we're looking at this box right here. We see that it's less than 0.05, so we know it's positive. And we know that it's a negative correlation just simply because this number is negative. Don't care about strength, don't think too much into strength when you're looking at this output. All you care about, is it significant? Is it a positive or negative number? That's all we care about. All right, in the chat, tell me depression and age. Is it significant? And if it is, only if it is it positive or negative? Depression and age. Okay. All right, so the answer is depression and age. Take depression and we go all the way over to age. It is not significant. We know that because 0.05 or 0.759 is way greater than 0.05. So it's not significant. So therefore, there is no relationship between depression and age. All right. So there were still people that got that one wrong. So please make sure that you go back, and I'll put out this weekend. I'll put out an example output. I'll create an output, and have questions that go along with it, and then I'll give you an answer key with it as well. Highly suggest that people who got these wrong today take a look at this this practice output and go through it and see if you can get the answers right. Once again, there's only two things you need to know. Is it significant by looking at this significance row? And is it a positive or negative number? I have a feeling that people who were giving wrong answers are probably overthinking it. Just, is it significant or not significant? Is it positive or negative if it does happen to be significant? All right. Once again, here are the outputs. All right. So in the chat, tell me, is it A or B? How do these two scatter plots differ? Do they differ in the strength of the correlation, or do they differ in the sign of the correlation? And the sign of the correlation, once again, is just positive or negative. So is it A or B? Good job. Everyone so far has been saying B. Yeah, so it's the sign of the correlation. We know that this one's a positive correlation because it's going, this way. Our slope is positive. This one, a negative correlation because the slope is negative. How about this one? Which correlation is stronger? The one on the left or the one on the right? All right, I'm seeing mostly A's. Good job. That correlation is stronger. And let me show you actually. All right, let me show you this graphically. So let me show you the strength of a correlation. And now that video, I believe, did talk about it, about how like if all the scores are kind of spread out, it's a weaker correlation, and scores that are more closer together is stronger. Let me show you that visually. So here is a real relationship between social media addiction and depression in adolescence, in this population that we collected data from. We see that there's a correlation of 0.241. If we would square it, we would realize that the correlation, that the R squared value, or that number that determines strength, is actually like 0.058. So it's there, right? It's not a super strong correlation. And we can see that visually in this scatter plot. So I can't make it any bigger, unfortunately. Actually, I can. All right. So here are all the scatter plots. So here's all these small little black dots are all the individual data points for this sample. This line of best fit, so let's focus on this red one. So this red line is what we would expect a perfect correlation to be. So an R value of 1, so a perfect correlation would fall, like all of our dots would fall on this red line. This blue line is actually our line of best fit. So this is the actual like slope of the line. And this line is just taking the means of all these dots, right? It's just the means of all these dots, and you plot it on this line. So we can see that like these dots are really spread out, right, from this line, right? They go really high and they go, kind of low. It's really spread out. Well, let me show you the difference in a really strong relationship. So looking at this output that I can't make any bigger, I'm sorry, we see a correlation value of 0.75. And so that's really big, right? That's a pretty strong correlation. And this is actually the correlation between depression and anxiety. So we would expect a big correlation between those two because they're like comorbid, diseases, I guess. Depression and anxiety go hand in hand. So look at this one. So we see that perfect correlation, that red line. That blue line is much closer to that perfect correlation. And we can see an R squared value of 0.57, and that's really strong. That's a really strong correlation. And you can see all these dots, you know, if I were to get rid of these lines, you can kind of tell that there's a positive correlation going on there, right? You know, these numbers, it tends to go higher. And you can plot that best fit line, that blue line, and we can see, oh, there actually is a positive correlation, and it's pretty close to 1. There's a really strong relationship here. So once again, just visually, can't make it smaller. You know, we have, you know, all these individual dots are spread apart, relatively weak correlation. All of these dots are kind of close together. They're a lot closer than the previous example, stronger correlation. So once again, strong positive correlation. All the dots are kind of bunched together, going in that positive correlation. And you can see here, we can still kind of see that negative correlation, but the dots are a lot they're spread further apart, which means that this correlation is not as strong. All right. Any questions about correlations that we talked about today? Talked about how to run it in SPSS, what the numbers mean. So you should be able to interpret it. You know, what is an R value, positive, negative. You can also look at R squared, talks about strength, and if it's significant or not. Relatively simple. I think correlations are probably the easiest statistical test to interpret. So you have all those skills now. So let's talk about assignment 11 and the quiz. So assignment 11 will be available by 4 p.m. I'm still editing it slightly. You're just going to be doing a correlation, interpreting a correlation output, as well as actually running the correlation from, I believe, a sample data set. No, it's this project data. So you're going to be actually analyzing your correlation from your data. And then, you know, answering some questions about it, doing the write-up for it. I would suggest that you do it separate from your group, but at some point text each other, email each other and say, hey, I got an R value of 0.2 and the significance value of this. Is this what you got? Just so that way you can double check. So it will be available around 4, maybe 5 p.m. I'll send an email out when it is available. I'm still editing it. But you will have time to work on it on Monday. So Monday's lecture is going to be kind of shorter, hopefully keep it under half an hour. And then the rest of the time will be for you to do it. I suggest doing it over the weekend. I'll send an email out, but I'll give you, let's say 5 points extra credit if you can get it done before Saturday, before like Saturday at midnight. So I'll give you 5 points extra credit, good way to get extra credit. But you do have time to work on Monday if you don't want to do it over the weekend. Quiz number, whatever the quiz is, I think it's 8 or 9, is due Sunday at midnight, like normal. But assignment 11, due by Monday at 3, extra credit if you get it done by Saturday. We don't have to do these. If you want to practice more, go to this lecture PowerPoint, and there's a couple questions afterwards to help you with the interpretation of scatter plots. Do that if you want to. I don't want to spend the time today doing it, so we can get out a couple minutes early. All right. Any questions about correlations, how to interpret them, how to run them, assignment 11 or the quiz? If you do, feel free to stay after class and chat. If you don't, be on the lookout for assignment 11 and the quiz opening. It should be definitely done by 4 p.m. I'm going to work on it right now. Other than that, I will see you all on Monday. But feel free to stay after class if you have any questions.